A cosmic breakthrough that's rewriting the universe's story. 128 new gravitational wave events just changed everything. In a stunning leap forward for astrophysics, a global alliance of scientists has revealed the detection of 128 previously unknown cosmic collisions, cataclysmic encounters between black holes and neutron stars that send ripples through space-time itself. This revelation more than doubles the total number of known gravitational wave events and marks a pivotal moment in our quest to understand the universe's most violent phenomena. But here's where it gets even more fascinating. These findings stem from the latest observational campaign, conducted by the LIGO-Virgo-KAGRA collaboration, a trio of cutting-edge gravitational wave observatories spanning the United States, Europe, and Japan. Their newly released dataset, known as the Gravitational Wave Transient Catalog, GWTC 4.0, covers the first 9 months of their fourth observational run, from May 2023 to January 2024, and is now publicly accessible via the archive preprint server. What exactly are gravitational waves, and why should you care? First detected in 2015, gravitational waves are subtle distortions in the fabric of spacetime, triggered by colossal cosmic events like the collision of black holes or neutron stars. These waves carry information about their origins and about the nature of gravity itself. Detecting them requires incredibly sensitive instruments capable of picking up signals smaller than a proton's width. And this is the part with backing from the Science and Technology Facilities Council and contributions from institutions like the University of Glasgow, University of Portsmouth, and Royal Holloway, University of London. British researchers have helped design and refine the ultra-sensitive detectors used in LIGO. Their work has also advanced the complex data analysis methods needed to interpret these faint cosmic whispers. Thanks to recent technological upgrades, these detectors are now 25% more sensitive than before. That means scientists can peer deeper into the cosmos, capturing signals from more distant and massive black hole mergers than ever. The discoveries are nothing short of extraordinary. Dr. Daniel Williams from the University of Glasgow's Institute for Gravitational Research, who led the data analysis team, emphasized the significance of this update. He noted that the new catalog showcases not only the power of international collaboration, but also the sophistication of modern data analysis techniques that can extract even the faintest signals from the noise. Among the 128 newly identified events is GW23814, the loudest gravitational wave signal ever recorded. This particular signal offers compelling evidence of black holes that themselves were born from earlier mergers, shedding light on how stars evolve in densely packed cosmic environments. Another standout discovery includes GW23518, which documents 2 rare collisions between black holes and neutron stars. But what does this mean for our understanding of the universe? The improved sensitivity of these detectors doesn't just increase the number of events we can observe, it also sharpens the precision of each measurement. This allows scientists to test Einstein's theory of general relativity with greater accuracy and explore the fundamental laws that govern the cosmos. Each gravitational wave event contributes to refining our estimate of the Hubble constant, the rate at which the universe is expanding. And here's where things get controversial. The Hubble constant remains one of the most debated numbers in modern cosmology. Different methods of measurement yield slightly different results, sparking ongoing scientific debate. Tessa Baker from the University of Portsmouth's Institute of Cosmology and Gravitation, who oversaw the new cosmology paper, expressed excitement over the release of these events. She highlighted how this influx of data has helped sharpen our understanding of cosmic expansion and confirmed that gravity behaves as predicted by Einstein's theory on large scales. This supports the current cosmological model, which includes perplexing elements like dark matter and dark energy, components that remain mysterious but are essential to explaining the universe's behavior. And the future? It's looking brighter and louder. With next-generation telescopes like the Vera Rubin Observatory coming online, scientists are poised to detect not just gravitational waves, but also the light emitted during these cosmic collisions. This multi-messenger approach, combining gravitational wave data with electromagnetic observations, could unlock deeper insights into the life cycles of stars, the formation of black holes, and the evolution of galaxies. So here's the big question. Do you believe the standard model of cosmology, with all its strange ingredients, is the best explanation we have? Or do you think we're on the brink of a paradigm shift that will rewrite everything we thought we knew? Drop your thoughts in the comments. Is Einstein still king, or is it time to challenge the throne?